Alright, this will go through the next 10 problems of the packet. I didn't realize that it went from 20 to 27, but number 27, I'm just going to reveal here. It asks for what is the distance between points B and D and the distance between D and K. Alright, is BD twice as long as DK? So you just got to use the distance formula twice, and when you check BD divided by DK, you get, if you use the exacts, you get exactly 2. Alright, if you divide these two, you also get 2, so it proves that DK is, or a BD is twice as big as DK. So the answer to that one, yes, it is twice as long, twice as big. Okay, so the second one, there's the definition of parallelogram, and if you look at this, the opposite angles are not congruent. Okay, now consecutive angles, if you check those, are not supplementary either. 18 plus 18 is not 180. So there's a couple different reasons why this is not a parallelogram. So the answer is no. Okay, number 29, it's a quadrilateral. It says it's a rectangle. So I know that's a right angle here. And that's pretty key because it says ABD, which is right there, is 2y plus 40, and CDB is negative 3y plus 51. Alright, so it says find CBD. Alright, so essentially these two angles are going to be the same. So here we go. 2y plus 40 plus the negative 3y plus 51 is going to be 90. Put those two together, you get negative 1y plus 91 equals 90. Subtract 91. Get negative 1y equals negative 1, so y equals 1. So when you plug that back in, you get 2 times 1 plus 40, so that's 42. So if that's 42, that's going to be 42. The reason I know that these two, because these are opposite interiors, right, remember that these two lines, these two sides are parallel. So I have opposite interior angles, or alternate interior angles, that are congruent. Okay. I don't want to skip too many questions, but number 30, we never did anything like this, so we're going to cross that out. The answer is 40, though. It's kind of intuitive that it would be 40. Okay, number 31, this one should go pretty quick. AD, A to D is 15. So AD, to find a ratio, I'm going to put it over in a fraction. So AD was 15, and then to EI, alright, EI, go from 20 to 40. So that's a distance of 20. So reduce that, and you get 3/4. Number 32. Determine whether each pair of figures is similar. Justify your answers. Well, remember similar figures. You guys like to say same shape, different size. Okay, but what does same shape really mean? Congruent angles or same angles. So they have to have the exact same angles, and then the different size, the sizes, the sides are proportional. Okay, and if you look at the angles, you have 71 matches up, but then the other two do not. So this criteria right here is not met. So there might be a double negative there, but no, they are not similar because they do not have the same angles. Okay, number 33. It doesn't tell us that these two triangles are similar, but with a little work, these two arrows mean that they're parallel. So I know that these angles are equal, and then these are vertical angles. So I definitely have similar triangles here, and similar triangles are proportional. I just wrote that down in the last problem. So I know I should be able to put a proportion together that 4 corresponds with 12. 4 to 12 should equal, remember I started small to big, should equal x minus 4 to x plus 2. And now I need to cross multiply. And when I cross multiply, I'm going to do 4 times that whole quantity. I'm going to distribute the 12, and then I'm going to distribute, same thing here, 12 times this whole quantity. It calls for distributive property. Oops. Well, x minus, I used the wrong one. X minus 4. So I get 4x plus 8 equals 12x minus 48. And what I would do is I would subtract 4x. I'm running out of room here, so I'm going to do it all in one step, and then I'm going to add 48 to both sides. So hopefully you got that. I kind of did it all in one step. That's 56 equals 8x. So divide both sides by 8, and x would equal 7. Okay, so it asks us for side AB, which is over here. So 7 plus 2 is 9, and then 7 minus 4 is 3. Okay, 34. You got to be careful here because you might want to use 5 to 6 when you're setting up your proportion. But don't do that because 5 is only D to E. Alright? But if this whole thing is 6 and that's 5, isn't AE 1? So really I have this 1 to 2 relationship from the sides. Alright, so there's a couple different ways you can do this. The small triangle, I would do 1 compared to 6, small to big. The big triangle is 6, the small triangle is 1. Alright, and then same token, I went from small to big. The other small side is 2, and then I got to think about this entire side. Well, if this side's 2 and this side's x plus 4, if I put these two together, don't I get x plus 6? Alright, so I set it up small to big, small to big. So now I cross multiply. Is that equal to each other? So 1 times that quantity is just x plus 6. 6 times 2 is 12. And this is really easy. X equals 6. So now it asks for BC and AC. Well, AC is this whole thing, so 6 plus 6, so AC is 12. BC is just part of it. 6 plus 4 is 10. Okay, 2 more. So 35. You got to realize that this is an isosceles triangle. It told you those two. Alright, therefore, since it's an isosceles triangle and this is the height of the isosceles triangle, it's going to cut this into 2 equal parts. That's the key. So those are both 5. So now to find x, all we have 2 out of the 3 sides of a right triangle. We can use the Pythagorean theorem. So x squared plus 5 squared should equal 11 squared. So x squared plus 25 equals 121. Subtract the 25. So we got 96. Square root both sides. You can leave that in exact form. But if you're going to do the square root of 96, it's approximately 9.8 to the nearest tenth. Alright, so this one here, that's 60, this is 30, so I got a 30, 60, 90. And the template that we drew was more upright like this. Alright, and the rule that we wrote down is that the small side was just A, the hypotenuse is 2A, and then across from 60 is A radical 3. Okay, so in this case, this is the hypotenuse right here, 24. So to find this small side, I just cut it in half. So the small side is always half of the hypotenuse. And then from there, since 12 is basically A, you can hear my daughter having a fit upstairs. This is 12 radical 3. Okay, there's another way you could get this 12 radical 3. Once you have 12 and 24, you could do x squared plus 12 squared equals 24 squared. You know, and you could basically just solve for x from there. Alright. So, either way, that's how you do number 36, and hopefully you got through the next 10.